Hi, my name is Bishra Habab, and this is my mini project for SI 261, Logistic Regression Analysis on the Iris dataset. I'm going to walk through summary statistics, a distribution visualization, how the logistic regression model is fitted, and finally, how predictions and probabilities are generated. First, let's go into descriptive stats. Here is the summary statistics table for the four numeric features in the Iris dataset: sepal length, sepal width, petal length, and petal width. This table includes the count, mean, standard deviation, and percentiles. The mean gives the typical value for each measurement, and the standard deviation shows how spread out the values are. The minimum, maximum, and quartiles describe how each feature is distributed across its range. Overall, the features follow consistent numerical ranges, and there are no unusual outliers. Let's talk about distribution visualization. For the visualization, I created a histogram of sepal length. The x-axis represents the sepal length values, and the y-axis represents how frequently each value appears in the dataset. The shape of the distribution is unimodal and slightly right-skewed, meaning most flowers fall around a central range with fewer extremely small or extremely large values. This suggests that sepal lengths vary, but they follow a clear pattern without any irregularities. Now, for slide 4, let's talk about logistic regression fitting. I fit a logistic regression model to predict whether a flower is virginica or not virginica. Here's the code that performs the fitting. I used model.fit parenthesis x underscore train, comma y underscore train parenthesis. Fitting the model means it analyzes patterns in the training data and learns how the measurements relate to the target label. During this process, logistic regression estimates coefficients that show how each feature affects the log odds of being class 1, which corresponds to the Virginica species. Once the model is fit, it's ready to make predictions on new samples. Lastly, let's talk about predictions. Using the fitted model, I generated both predicted class labels and predicted probabilities for the test set. The probabilities show how confident the model is that a sample belongs to class 1 Virginica. Class labels, which are either 0 or 1, represent the final model decision. These class labels are created using a default threshold of 0.5. If the probability is 0.5 or higher, the model predicts 1, which is Virginica. If the probability is below 0.5, it predicts 0, which is not Virginica. This is how the model converts continuous probability values into discrete predictions. That wraps up my project. I reviewed the data set using descriptive statistics, visualized one of its features, trained a logistic regression model, and explained how its predictions are generated. Thank you for watching, and thank you for a great semester. Go Blue.